In this chapter, I will introduce user-accessible quantities and direct variable access. At first, I will explain what are user-accessible quantities. After that, I will show the use case of UAQ. Third, I will introduce what is direct variable access, and at last, I will show some examples of DVA. So, let's get started. What is user-accessible quantities? CarMaker is a C-code-based simulation software. There are many C-code variables which normally the user cannot get access. For this purpose, we bring the data dictionary concept. If the internal C-code variables are added to the data dictionary, the user can get access to the variables, and we call these variables user-accessible quantities. What can we do with user-accessible quantities? We could use UAQs to store the simulation result. Second, we could also watch the UAQs in IPGMovie or IPGControl. At last, we could also use DVA function to read or overwrite the values of UAQs. I will explain this function later. So, except the already defined UAQs in CarMaker, we could also use C-code symlink or real-time expressions to define the new UAQs here. The question, where can we find the name of our quantities and how to use them? To answer the first question, I will open the reference manual to help us find the names of UAQ. Here you can see there is one chapter called User-Accessible Quantities. In this chapter, under driving maneuvers, you can find different names. The name of UAQ, the name of the C-code, name of CarMaker for Simulink, and we can find small descriptions for each quantity. If we want to use UAQ, we should choose this name. For example, DM brake. And also in the mini maneuver, you could use right-click and browser to have a look at all the quantities. If we choose brake, OK, you could use this name. At last, we have a look at IPGControl. Here you can also find all the quantities. And if we choose DM brake, you could see the values of the simulation. That is the use of UAQ. Before I introduce the DVA function, let's have a look at CarMaker's main simulation cycle. The simulation starts from left to right. There are many different modules. For example, DriveMan. This module has DM gas, which is calculated by maneuver control. We also have the vehicle control module. This module has VC gas. If we want to not only read the values but also override the values, in this time we could use DVA functions. There are many different possibilities. We can use DVA after the DM module or after the brake control module to read the UAQ's name and override the values. I will show some example to explain the usage of DVA function. Now I will open DVA dialog under Application. You can find this option. At the left is Quantity. There we could choose one UAQ. And for example, DM, we can find two types of UAQs. The first, the UAQs with the blue font. These UAQs are overwritable, but there are also the normal UAQs that cannot be overwritten. We could just read the values, so I will give two examples first. Let's use DM brake and DM speed limit. So you can see the difference between these two UAQs. For DM brake, we could read the current value here, set the group for many UAQs, and if we want to set a new value, we can do it here with a specific duration in milliseconds. For DM speed limit, we cannot do this. In IPGControl, we can see the standard break value here. It's 0.6. For example, I want to override it with 0.8. We can define the duration, but I want to override this value all the time. So I give it -1. I set this value and start the simulation. As you can see in IPGControl, the value has changed. It is now always 0.8. Not only in the DVA dialog, we could also use DVA in mini-maneuver commands. Before we use it, we should follow this format. DVA write is a prefix, afterwards comes the quantity name. In this example, we use DM break. The next one is mode. There are the different options for it. ABS specifies the absolute value. Off could define an upside which is added to the current value. And you could find more information in the user's guide. Then we need to define the duration. The unit is in milliseconds, so if we use 5000, it means it is 5 seconds. If we choose ABS mode, we just need to define one value. If we use phase off or phase ramp, we also need to define the second value. If we use ramp, we also need to define the number of cycles. Let's go back to this example. Before this comment, we could also set a condition. If this condition is fulfilled, the DM break will be overwritten to 0.5 for 5 seconds. I will show you one example. Let us have a look at the first example. This is a basic braking test run. The first maneuver step is acceleration. Second, we give a 0.6 brake value. You can see it here. If we want to override this brake value in some condition, we could use DVA. Here I will give you an example. You can see that we use a UAQ called step time, and if it is bigger than 10, we override the brake value for 5 seconds with 0.8. This value stays there for 5 seconds. Let's have a look at the simulation. You can see that after 10 seconds the value is 0.8 and 5 seconds later it will return back to 0.6. So this is the first example. I will show another example. In some cases we want to change the value continuously. So in this time we could use a ramp mode and we copy this comment here. As you can see, the step time is bigger than 10 and then the value will be increased from 0.6 to 0.8. Because this is ABS ramp mode, we also need to define the number of cycles now. It is 3000. It means in 3 seconds the value of 0.6 will be increased to 0.8 continuously. Let us have a look. What are the outputs? So, as you can see, the value at the start stays at 0.6 and after the 10 seconds it will continuously rise from 0.6 to 0.8. Then it will stay there for 2 more seconds and will go back to 0.6. This is a use case of ABS ramp. Okay, until now I introduced all the functions. Thank you for your attention.